Discuss the continuity of the following function. If there is a removable discontinuity, describe how this could be removed. So we have f of x equals x squared when x doesn't equal 2, so everywhere but 2, but f of x equals 6 when x does equal 2. So that is a strange type of graph. Well, let's try and draw it. We should all know what x squared looks like. So let's get some x's. So x squared kind of goes like this. Okay. And it's fine. This graph is absolutely fine apart from when x equals 2. So you know, mine's always a bit flat, but basically, let's say this could be the point, say 2, when x equals 2, and we have 2 squared is 4. Right, it's a terrible scale, but never mind. 2 squared is 4. So basically, there's a hole in the function there because it says that it doesn't equal x squared when x is 2. It actually equals 6 when x is 2. So what that means is, terrible scale, but if that's 4, then that must be 2 and that must be 6 there. So I'm going to have it actually is 6, so I need to have a filled in circle to recognize that that's included. So this is y equals f of x, and this is what the graph looks like. So it's very strange. You have perfectly normal x squared graph everywhere, but then where x equals 2, you've just got this sort of strange value that doesn't make sense. So as far as the continuity goes, remember, to be continuous, you need the function to be defined. To be continuous at a point, the function needs to be defined at that point. Also, the limit, as x approaches that particular value from both directions, it needs to be equal, and it needs to equal the value of the function at that point. So that is absolutely fine everywhere apart from this obvious problem here. So let's have a think. So f of x is continuous for all real x, but it's not continuous here, x. There's clearly a problem when x equals 2, so let's have a think about that. So for f of 2, it is defined, but it equals 6, right? Now, that is enough to know that it's the fact that the value of this clearly isn't the limit bit. Let's just write the limit. So the lim, as x approaches 2 from the left-hand side, equals, well, as we're approaching 2 for the left-hand side, you can see that f of x is approaching 4. Let's go from the other side. Lim, as x approaches 2 from the right-hand side, when we go that in, we're also approaching 4. Right, so we have a limit. That's clearly showing us that the limit, as x approaches 2 of f of x, equals 4. So the limit exists, so that's a good start. If a limit exists, then it means that we don't have an essential discontinuity. But we definitely have a discontinuity because f of 2 does not equal the limit as x approaches 2 of f of x. So we have a discontinuity, but because this limit exists, this is classed as a removable discontinuity. So f of x has a removable discontinuity at x equals 2. So then we have been asked, if there is a removable discontinuity, describe how this can be removed. So this would be removed by redefining the value of f of 2, basically. So this can be discontinuity can be removed by defining new function So we'll call it g of x. And g of x equals, so we need this sort of piecewise notation. If we look at the original, we said it was always x squared when x doesn't equal 2, and then it would just have to be 4 when x equals 2. So if we have that, that actually gives us a continuous function, and it is a bit silly really, because if you think about this, this is just the same as saying g of x equals x squared and not even having a piecewise definition.